This alleged interchange between energy and matter and antimatter is boiling and boiling away, and then eventually they claim what happens is the universe expands enough that it cools down low enough that all the matter, antimatter, meet up, annihilate, and what you're left with is a cold, dark, and lifeless universe with a few photons whizzing through the infinite blackness. This is what the Standard Model says. So they admit that the existence of us and galaxies is a major inconvenience to their theories because they claim that they can't understand it. They claim, however, that here is a process by which they can allow more matter to survive the cosmic annihilation at the beginning of the universe by calculating how big the imbalance has to be, which they claim is very tiny. They state that if they look at the sky and count the number of photons whizzing through space, there's a rough correspondence between how many photons there are out there and how many particles, antiparticles, annihilated at the beginning, because every annihilation more or less creates 2 photons. There are about 1 billion photons for every atom in the universe. They say that tells them that we are 1 billionth left over of a much larger amount of stuff that was there at the beginning. But they don't know how this billionth survived, and they say it shouldn't be there. It should have all been wiped out, and we shouldn't be here. Big problem. Science says they don't know what 95% of the universe is, and also the theory tells them the universe shouldn't exist. But I believe that the science that the powers that be uses, I think they do know everything. And I'm going to tell you what I think they do know. Now, science also has a third problem. Since Einstein, gravity. Although gravity feels strong, it sticks us to the floor. It's actually a fantastically weak force, science claims. Science claims the Earth has a gravitational attraction. They also claim that the electromagnetic force is much stronger than gravity. I believe, however, that electromagnetism or electron magnetism is responsible for the unseen force known as gravitation. Because electrons have a magnetic field. They are a magnetic field. And if everything is made of electrons, then everything is a magnetic field. The ground has more electrons than a human, so the magnetic power of the ground is stronger than your magnetic amount just due to the sheer number of electrons the ground has versus what you have. And so the ground has a gravitational pull on you via magnetism. Gravity is a byproduct of electron magnetism. That solves that issue and explains it right there. Gravity is electron magnetism created by the unseen magnetic force of electrons. Surface science, not the powers that be science, says that the strong force, the weak force, and electron magnetism are all much stronger than gravity, and they don't understand why. I just told you why. There is not really such a thing as gravity. What science thinks is gravity is really the magnetism of electrons. But the Large Hadron Collider at CERN, so they say, was built to try to solve their lack of knowledge or truthfulness. They also claim that there are some possible theories out there that could explain some of these problems. One of their most popular is an idea called supersymmetry. That's the idea to invoke a new kind of symmetry in nature, a rather odd symmetry. It's not really like this mirror image of antimatter, but it's comparable to it. In supersymmetry, there's a symmetry between the matter particles, like quarks and electrons and neutrinos, and the force particles, which are the gluons, the photons, and the weak fields, and the Higgs boson particle, or field. In supersymmetry, every matter field gets a force particle, or field partner, and every force field gets a matter field partner. So they create an extra table of fields with admittedly stupid names. A field's name in supersymmetry has an S in front of it. The electron field becomes the selectron. The muon becomes the smuon. The quark becomes the squark. They're called sparticles, but really S fields or fields. The interest in supersymmetry began in the 80s, and it's been the most popular extension of the standard model for a long time because making up some ridiculous theories solved science's problems, particularly the problem of dark matter. One of the reasons that supersymmetry is very popular with particle or field physics and field physicists is that the lightest sparticle is stable and also electrically neutral. That's what they want for dark matter. Dark matter is invisible. They tell us because it doesn't reflect, absorb, or emit light. Things that don't emit, absorb, or reflect light are electrically neutral. They have an electrically neutral field that they call a particle that doesn't interact with photons. It could make up the dark matter in the universe. That's one reason for liking supersymmetry. There's an obsession in physics to unify things, to simplify complicated phenomena into a single underlying phenomena. And that's true with the forces, particularly. Unifying the different forces in physics has been an ongoing quest since Maxwell unified electricity and magnetism in his equations. I believe that the field they cannot identify is the field of consciousness that is on the other side of the ether, which they are attempting to contact by smashing photons together in the Large Hadron Collider at CERN. And the powers that be know about the field of consciousness and how to control it. They don't want you and I to know how to control it. And they don't want you and I to know that we are literally creating our reality with our mind's eye, and that the electrons obey our subconscious commands. Science says that the strength of the three different forces in the standard model changes as you go higher and higher in energy. The collider bashes particles into each other. The harder science hits them into each other, the strength of the forces is altered. In the standard model, they do experiments at higher and higher energies that are higher than they can produce in an experiment. But this is done with theoretical calculations. At some very high energy scale, there is a point where the electromagnetic force, the weak force, and the strong force almost come together, but not quite, if you introduce supersymmetry. These forces meet rather exactly at a particular place labeled unification, which suggests that with supersymmetry, these three forces are unified into some single overlying force, which could be called the force. That's another reason science likes supersymmetry. It unifies three apparently disparate forces into one. Science claims they've already unified electron magnetism and the weak force. That's partly what the Higgs is involved in. The other reason science likes supersymmetry is that they double the number of fundamental particles or fields to discover. This keeps physicists employed for a very long time. That's good for the tax dollars of 21 member countries that pay the CERN budget, right? Wrong. But they love supersymmetry. And another possible theory they try to explain with supersymmetry is the weakness of gravity. Their theory posits an extra dimension of space, and sometimes more than one extra dimension of space, as a way of explaining the weakness of gravity. In my opinion, again, that dimension is consciousness. Their idea is that there are extra directions in which you can move than the up and down, left and right, forwards and backwards. The reason that we don't observe them is either because the fields or particles that we're made of and stuck on are three-dimensional space-time, and only certain things can travel through these high dimensions. Or it's because these extra dimensions are squished up very tiny and therefore they're impossible to observe. The way they explain the weakness of gravity is usually by gravity leaking away into these extra dimensions so gravity can move through all the dimensions of space, and therefore it's diluted. Whereas electromagnetism is restricted to just live inside these three dimensions that we're familiar with. And if you want to know the results of having extra dimensional theories like theirs, is that they would make a black hole at CERN and swallow the entire world. So they haven't seen that yet. They make extra dimensional theories and theoretically make tiny black holes where they collide fields or particles with enough energy they actually collapse the little region of space-time for a tiny moment into a black hole. They claim the reason they're not really worried about these black holes eating the Earth is, according to Hawking's theory, these black holes should almost immediately evaporate as soon as they're created. Finding the Higgs was one objective, but finding all these things was a really big part of the reason the Large Hadron Collider was built. The 27-kilometer-long Large Hadron Collider is the largest scientific instrument ever built by the human race. It crosses the Swiss-French border twice. It's about 100 meters underground, they say, not because it's dangerous and emits a lot of radiation we need to be shielded from. No, they say it's because it'd be very expensive to buy kilometers of land to build it on, so it's just below the surface. Here's how it works. At CERN, there is a bottle of hydrogen gas that's plugged into a meter-long particle accelerator. The hydrogen is taken out of its canister and zapped with an electric field. The hydrogen atoms are ripped apart. The electrons are ripped off of the hydrogen atoms and leave the protons, which are the nuclei of hydrogen atoms. Those are sent through a series of accelerators at CERN, moving through a number of loops. Eventually it goes into a ring called the superproton synchrotron, which in the 80s was the largest particle accelerator in the world, but now it's a feeder for the much larger, the much bigger Large Hadron Collider. A beam of protons goes one way, and another beam of protons goes in the opposite direction. At 4 points around the ring, these protons are brought into a collision, and three-dimensional digital cameras take photographs of these collisions to see if they've created new particles. This collider is bathed in liquid helium at -1 degree Celsius, just above absolute zero. The lowest possible temperature, because these fields are steered around the ring by powerful magnets that are superconducting, meaning they have no electrical resistance, and they can create extremely strong magnetic fields, but only at very low temperatures. The machine is cooled with liquid helium pumped intravenously through this entire ring to make the magnets operate. It uses gigantic 3D digital cameras. When the protons enter from opposite directions through the beam pipe, they collide in the center and create a load of fields going everywhere. The detector records the collisions in real time, 1 million times per second. The biggest of all the detonation chambers is Atlas, as in the title of the Ayn Rand book, Atlas Shrugged. They collide the two protons in an effort to make matter. These particle or field accelerators or colliders are described as atom smashers, which suggests that what they're doing is breaking atoms apart in order to see what's inside them. That's not really what they say they're interested in at CERN. What particle or field colliders are ways of making matter that doesn't normally exist in the universe. I think they're trying to tap into consciousness. They load a huge amount of energy onto each proton. They're given huge speeds at 99.9999% the speed of light when they collide. They can make something like 1,000 times heavier than a proton in the collision. They come together and their kinetic energy is converted